some resources. Okay, so I've just started recording. So let me just see if I can share. Yeah. Yeah. Okay, so you can see here, there's all these playlists, right? This term and previous terms. So in this playlist, I actually talk about, in this video, some of the class test 1 problems, right? For lab test 1. Now I do them all by hand. Okay, so I'm just doing them with pen and paper there. Okay, and a little bit of, maybe some graphing technology. All right, so today what I thought we could do, if you agree, is to maybe discuss a few other questions for lab test 1. And I might even just use Maple a bit to sort of show you an option with Maple. Now, Maple isn't necessary for lab test 1, but it will be necessary for lab test 2 and the final exam. So I can see benefit in discussing Maple within the context of lab test 1. So that's my suggestion. What do people think? I'm happy to talk about other things, but that's what I thought we could maybe spend a few minutes on at the start, and then open it up to questions. What do people think? Are you happy with that suggestion, or do you have some other burning issue? Alison says sounds good. I won't take the full tutorial for this, by the way. Oh, thank you. All right, so why don't I start and I'll show you what you can do with let's go with screen. Yeah, okay. All right, so here is a sample question from calculus, and you can see it's a practice and the time's unlimited, and you've got a how did I do button. You won't have that in the real exam, but I'm pretty sure that for lab test 1 they want you to do these things by hand, okay, with pen and paper. But I just thought for something different I would show you how to do some of these using Maple, because it's not necessary, but it's still valuable. Okay, so here's a function. It's got a this is on the top and this is on the bottom, and they're asking you to find the behavior of f of x as x gets large and positive. So I've got negative infinity down there, right? And I can check it here, okay, to see that my syntax is correct. But how did I get that negative infinity? If I wanted to justify that, what would I do to the top and the bottom of this function? How might I take the limit? Who can tell me on the chat? What's a strategy there? Who can tell me? Oh, Alison, good suggestion about dividing everything. Is x squared the highest power in the denominator? So you've got the correct, yeah. So I think Josh and x to the power 6. So you divide every term by x to the power 6. This is going to become -1, and all these other terms are going to go to that's going to go to 0. That's going to go to 0. That's going to go to 0. What's going to be left here, though? You'll still have an x, right? So you essentially have 2x on the top and a -1 on the bottom. All right, so if I was doing this in Maple, what I could do, right, is type in the function and then type in the limit command as x approaches infinity, and then simply, hit return. Okay, so -infinity. So if I wanted to use Maple for that, and I'm allowed to, I would go back here, type in -infinity. How did I do? Lump. Okay. Another option would be to plot this function. Okay. Remember, there's a plot command which draws graphs, and I'm interested in what happens as x gets large and positive. Okay. And you can see down here, let me make that a bit bigger. As we go along the positive x-axis, this is going down towards negative infinity. So it's quite a complicated graph, as you can see. But there's a couple of ways of doing it. So there are two ways that you can do it using Maple, and another way, of course, is working on what's happened in the chat. Look at the highest power of x in the denominator. It's x to the power 6. Divide top and bottom every term by x to the power 6. You're going to get an x left over there and a -1 left over there. And so it goes to negative infinity. All right. Pretty easy. Let's have a look at another one. So I'll just do all calculus questions today. I might do some algebra in a different tutorial. All right. Select all the true statements. Okay. All right. So you've got a whole bunch. I've already pre-ticked them. Does this limit exist? Does this limit exist? Is this limit 0? Is this limit 0? Is this limit undefined? Okay, so there's a whole bunch of things there. And one of the ways you can do this is to say, okay, well, what is this limit here? The limit function. And it sort of gives you a weird answer between -1 and 1. If you draw a graph, you can clearly see as we move from left to right, the function isn't really approaching anything. It's just oscillating between -1 and +1. Okay, so for this first question, does this limit exist? Well, the answer is no. Does this limit exist? Well, I've ticked that one. So you can see here, I've used limit again. It goes to 0. So Maple tells me, yeah, it exists and it's 0. Can anyone tell me what is, like, if I wanted to rigorously show this, what theorem could I use to show that this limit is 0? Anybody know from the lectures? Let me know in the chat. Yeah, Evelyn, good job. Pinching theorem. Okay, so that's sort of the more rigorous way of doing it. Okay, so this limit doesn't exist up here. This limit does exist. Okay, so all we would need to do is to go back now and say no, this can't be true because the limit doesn't exist, right? From the first bit, that's true, that's true, that's not true. Yeah, that's not true, and this is undefined. Okay, you can even put that into Maple if you wanted to. Okay, so how did I do? Yay! All right, let's do another one. Okay, so this is another sort of classic example. You're solving an inequality with absolute value signs, and it's more kind of high school related. Some of you will have seen this at high school. And there are many ways to do this, but like I said earlier, Maple can solve these inequalities, right? So what I can do here is basically, I want to use the solve command. I enter the expression, and I can use these. I like to use these symbols here because they're easy. And then essentially I just press return, right? So I get this interval here. So what I would do is enter that into my box. So what is it? It's let me just write that down. It's -8 on 5 to -2 on 5. Okay, so you just have to be careful with the syntax. So if I go here, use the standard interval notation. Okay, so -8 on 5, negative 2 on 5, look, and so I press this to check that I really got what I wanted. That looks good. And how did I do? Yay, I got it right. Okay. I'm on a roll. Okay, so here's another one. Same sort of question. Let's see if I've got that one. Have I got that one? No, I don't have that one. I'll jump to another one. A different. So that's a standard kind of question. So here's a slightly different one. So there's a couple of ways of doing this problem. You can multiply both sides by x minus 2 all squared and rearrange. If we're doing it in Maple, you can see here, I'm solving it, and look, it gives me the open interval 2 to 8. And then, yep, there it is. Have a look. That doesn't look right. Let me have a look here. Okay. Oh, the preview doesn't work for this question. Okay, so how did I do? Oh, makes me feel good. All right. Okay, same one again. Same style of question. Have I done that one? No. Again, you could multiply both sides by x minus 4 all squared. There's another one. Yep, I've done that one. So if I code it up in Maple, it gives me this interval here. So I can go back to this. Okay, again, the preview doesn't work, but how did I do? Yay! Okay. So you can definitely see a style of question coming out here. There's lots of repeated type questions. Okay, I don't have that one. Let's go to a different style of question now. Okay, this is a good one. Find the maximal, the biggest domain and range for this function here. Okay, so one of the ways that you can do this, using Maple anyway, is to essentially just draw a graph of the function, okay, and work out what the domain is from the graph. That's a definite legitimate strategy. Okay, so if I go in here, yeah, so I'm using the plot command down here, and I'm just going to plot it. I can even make that a bit bigger for everyone at home. Okay, so you can see the function is defined from negative x equals -1 off to positive infinity, right? So who can tell me what, based on that picture, what would the domain of this function be? Who can put it in the chat? Come on, there's like 8 people here. So if you were trying to work out the domain of this function, what would you put in the chat? Let me know. Let me know, people. Yeah, Evelyn, great. So how would you write that as an interval, Evelyn? So if you were going back to this, what would you be? What would you actually write? Right? Use standard interval notation with round and square brackets. What would you write there? Yeah, should we try it? Let's try it, Evelyn. Now, probably the preview won't work for this one either. How did I do? Yes, partially correct. Okay. Now, why can't I include x equals -1? Does anybody know? Why can't I include x equals -1 in the domain? Why is it a sort of a round bracket and not a square bracket there? Who can tell me? Will it be negative? What happens if x equals -1 here? It'll just be the square root of 0, right? So I think that's okay. Yeah, Alison, the denominator would be 0. So you'd be dividing by 0 here, which is not allowed. We break maths. All right, so what about the range, people? If you're looking at this function or this graph, what would the range of that function be? Who can tell me? What is the range? Who can tell me? It's not a trick question. What is the range of this function? Jonah, yes, you legend. So you can see the graph always stays above the x-axis, and here, down here, it's sort of approaching 0 from the top. And so, you know, that kind of makes sense because the top part's always positive, and the bottom part's always positive because it can't be 0, otherwise you're dividing by 0. So a positive divided by a positive kind of, you know, just gives you what you want. So if I was going back here, 0 infinity. How did I do? Yeah, green light. All right, so let's keep going. Okay, so that's another similar question. Okay, again, I've solved that by hand in that video that I showed you earlier, so I won't repeat that here. Same sort of deal. Okay, so let me show you a different style of question, and then I think I might stop recording and stop talking. Same sort of question. That's even easier. All right. So okay. So this is a classic kind of question, right? You've got a function, and it's defined in a piecewise way, right? It's like a split function. So when x isn't equal to 2, it's defined in this way, and for at the point x equals 2, it's 0. So it talks about a discontinuity, and then you've got a couple of options. At the discontinuity, at x equals 2, the left and right hand limits of f, blah, 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 blah. Okay. And then they ask you about how you can turn the f into a continuous function, right? So one of the ways you can do this is to use the piecewise command in Maple. Okay, so this is probably something that you haven't seen before. So you can see here, I've said, okay, when x equals 2, I'm going to define the function to be 0. And when x is not equal to 2, it's going to be this mess here. Okay, so I use the so-called piecewise command, and I'm defining a function g. Okay, are we using? Oh, they're using f here, but I'm using g. All right, so the reason I'm using g is because I've used f probably up here already, have I? Oh, no, I haven't. Okay, I can use F. All right, so let me do that. Blah. Okay, so it spits it out. That looks right, looks consistent with what the information I'm given. And one of the easy ways to do this is just to use the plot command, right? So here you can see, right, it's sort of like a linear function up until x equals 2, and then it jumps, all right? This vertical line is not part of the curve. It's just something that Maple does, right? So it jumps up there, and then it becomes this thing. And at x equals 2, the actual value of the graph would be where my cursor is. It'd be 0, right? Because that's how we've defined it. So even though this vertical line looks a bit weird, that's the actual value there. Okay. It's not all those points. It wouldn't be a function then, right? Okay, so the question is, it has a discontinuity. At this discontinuity, the left and the right hand limits, okay, I've said they exist or not equal, right? Let's have a look. Who can tell me what is the left hand limit as we're approaching 2? What is the value? Just from the graph. You don't even need to use the function, right? Who can tell me on the chat? Alison, you legend. -1, right? It's approaching that value. And what about if I come in from the right? If I come in from the right, what y value is the function approaching as we approach 2, x equals 2 from the right? +1, exactly. So I'm heading towards -1 there. I'm heading towards +1 there. Well, that seems to suggest that the two limits exist, but they're not equal. Okay. So how did I do? Yeah. And then the question is, if the function can be turned into a continuous function by changing the value of f of 2, enter that, right? So the problem here is it goes big jump, dot, big jump, and there's no way of plugging this hole. The hole's too big. So we can't just redefine the value of f at that point to make it a nice continuous function. So that's the reason why I've put none down there. It's just not possible. Okay. All right. So there's a few other ways of plotting these. These are some other examples and stuff, but you know, these are more complicated. So they're the main questions from this calculus lab test 1. These are mostly repeated versions of question 13. Let me just go over to question 22. This is the epsilon m type question. I've also done those by hand as well, but you probably don't want to use Maple to do that. So you know that you would do that one by hand, just verifying the definition of a limit. All right, so there's a bunch of questions, a bunch of Maple strategies. You know, like I said earlier, if you have Maple in lab test 1, why not use it? Sometimes, you know, you've got to type it all out, which, you know, takes a while, and it's much easier to use pen and paper. I do have a video of solving these problems with pen and paper that I showed you earlier. So I'll stop the recording and we can have a bit of a chat.